So fine. The first problem we have solved with some single point load. Then this problem, again we have to find out the support reactions of this beam, in which it is, the setup is like this. There is one hinge. This is a hinge support. I told you that looking the shape of the sketch, this shows it's a roller support. This indication it's a roller support, and without a roller, this is the shape of the hinge support. So this one end is an hinge support, other end is a roller support, and you have three types of loads applied here. One is a point load, a single point load with 6 kilonewton, and the second one an 8 kilonewton here, 8 kN and 10 kilonewton. This 8 kilonewton is with an angle of 60 degree, okay, and 10 kilonewton is an angle of 45 degrees. This is the nature of the load. So the distance of the individually from point A to B here, you can take C, D, E, etc. Okay, take this C, this is D, this is E. Any points you can take. So the distances are given as 2 meter, 1.5 meter, 3 meters, or 0.5 millimeter, whatever it is. Now the purpose is to find out the solution. What you have to first to do, already the same problem was repeated like previous one. Only change here is there are two inclined loads are given. Okay. So now here the first step you have to find out sigma h, that is horizontal loads what are available. And before going to this answer, as I told you in the previous problem, you will have to modify this diagram and write it, because the hinge support has got some rules. What are all the reactions possible for a hinge support that we have studied. Hinge support means you should have one vertical reaction and also an horizontal reaction. A roller support is the first kind of the support where it has only the vertical reaction. The third one was fixed support, which has a vertical, horizontal as well as the rotational load, right? So before going for the solution, you will have to first step is to write a diagram, a modified diagram, so that easily you can carry out the solution. Right. Now the same thing. No, I'm not going to erase it and write. So you have to write a new diagram. That is the rules is that. So I'll just indicate one. This is called VA, vertical at point A, vertical reaction, and there will be one horizontal reaction also, something called HA, horizontal reaction at point A, and this I am indicating arrow mark which is away from this point A. And I told the reason for why we are writing this in the previous problem. Why? Because the horizontal reaction is assumed to be acting outward from the point, but after solving the particular reaction, that is, if the value of HA, if you get a positive value, okay, you should treat as such. That means it is acting away from the body. The assumption what we assumed is correct. Suppose if your HA value is a negative one, you will have to modify, rewrite this direction as opposite side. That is the only change in hinge support, because you have one vertical reaction and horizontal reaction. Answer of HA depends on its value. If the value is positive, you leave this HCA, which is assumed to be acting out of the point, outwards. This arrow mark is good. It holds good if the answer is positive. If the answer is negative, you have to write it in the opposite direction. That's it. This is the only change here. And roller support, what you have here, I'll write it here. I'll just show an arrow mark. You will have to indicate this separately. This is your VB, only vertical you have. You don't have any horizontal reactions here. That's what the condition is. Roller means only vertical reaction, and your hinge means or vertical and horizontal. Okay, right. Now the next step, what is the modification required here? If I have only the vertical load, that is fine. What arrangements made is right. But there is some inclined loads also. If an inclined load is given, it is our duty to modify this inclined load divide into two different components. You are resolving the inclined force into two different components of horizontal and vertical forces, then start the problem answering. Which means this alone I am telling, since this is inclined, okay, with an angle of, say I will take an horizontal line, angle of how much? 60 degree. What you have to do? You should always introduce one vertical What is this? Same 8 kilonewton. This is force 8 kilonewton, and then one more an horizontal load of 8 kilonewton. Right? This is 8 kilonewton only. It is acting at 60 degree. We have to introduce two loads of horizontal and vertical so that you can take out this value. In the sense, the 60 degree should be written in terms of these two horizontal and vertical loads. How do we write it? As we done in previous unit, it is 8 cos 60. I hope you all understand. You know that why we are writing cos here in the horizontal side. Okay, and here it should be 8 sin 60 degree. Is it okay? This angle, an inclined force, is being resolved into an horizontal and vertical force. Horizontal is 8 cos 60, vertical is 8 sin 60. So this is how you have to write. That means at this position, the second sketch should contain these two forces with a value of 8 sin 60 and 8 cos 60. Is clear? Then what is left out? Which means this 6 kilonewton is direct load, downward load, vertical load. It remains as it is. Second point, at point D, you should have two loads like this, two forces. And at point, suppose E, you are indicating again this 10 kilonewton of inclined force with an angle of 45 degree should be resolved into horizontal and vertical like this. So what will I do? I am just writing the nature of this. Is it okay? This is 10 kilonewton, 10 here. Introduce one horizontal and one vertical. The angle was 45 degree. So which I will take it out. Okay, I will indicate this is your 10 sin 45. Okay, 45 45, and this is 10 cos 45. Arrow mark is just because kindly remember, wherever the arrow mark which comes in the inclined force, we have to see that the horizontal and vertical components should come and meet in that arrow mark point. That's what we studied in the unit number 1. The same rules, set of rules holds good for any force you are finding its components, resolving its components. That's it. So this becomes 10 cos 45 and 10 sin 45. What I mean to say, this sketch is modified with these two forces. The inclined forces are resolved into horizontal, one horizontal and vertical, horizontal and vertical. So this is the final setup where you should write this sketch. Then go for this answer. Clear? Now we go for sigma h, horizontal solving. Now sigma h, what will be there? What is the forces are there? How many forces are there here? Sigma h, this HA will be one force. HA is going towards left hand side. I will write minus HA. It's suffix A. Clear? Then you will go for what is this? This is another horizontal force, 8 cos 60 acting towards left hand side. Again it's negative. It is minus 8 cos 60 degree. Okay. Any other horizontal force are there? Here are one another force. This horizontal force, value of 10 cos 45 acting towards right hand side, so it's positive. It's 10 cos 45 degree. This is the answer. You will get a value for HA. The calculations I am not writing. Okay, you will have to calculate. Say suppose some value x Newton, kilonewton, sorry. You find out a value. Okay, any value it is. If it is positive, if your HA value is positive, the assumed direction of HA, which you are assumed as, it acts outwards the point of load, this point A is correct. Suppose you get a value of HA is negative here, what do you do? You should change the direction of this HA. That's the work. Now HA is over. Fine. Now sigma h is that. Then you go for vertical. All the vertical forces you have to calculate. What are the vertical forces available here? VA is one vertical force acting up. I will write VA positive. VB is also acting up. I will write plus VB because acting up. Anything else? Vertical forces. Is one vertical force 6 kilonewton acting down, will be minus 6. Come to the next one. It has been modified like this. This 8 kilonewton is like this now. 8 sin 60 acting down, again minus 8 sin 60 degree. Then anything else here? 10 sin 45 is another force at point E, okay, acting down. So it's 10 sin 45 degree. Okay, so you will get an equation VA plus VB, some value. Okay, now what you do? You find out the answer first. This VA VB will be a combination. Now what is there? You know HA, some answer will be there, some X Newton. VA plus VB will be some, Y kilonewton, say some value. I am not calculating the values here, right? Now the unknown will be 1, either one. To find out that one, what you have to do? You go for moment. So moment is the one. See, the equilibrium condition is based on your sigma H, it is horizontal, summation of horizontal forces, sigma V, vertical forces, and your moment. So moment about any point, suppose a point A, this point A. The moment what you are doing, you take all the forces into, multiply into perpendicular distance of that, take a moment. Is it clear? Now what you do is this, sigma m is equal to 0, what will you do? 1 by 1. First force HA acting on the line of action at point A is 0. You can write HA is equal to into 0. Then you go for VA, you want to go, again you write plus VA into 0 because acting in the same line of point. Then 6 kilonewton acting clockwise the distance of 2 meter because it has to come towards point A, because we have taken moment about point A. This 6 is acting clockwise, plus 6 into 2 meter, plus 6 into 2 meter, 2 meter or millimeter, whatever it is, the value given. Then into, you have these two forces, 8 sin 60 and 8 cos 60 here at this point D. With 8 cos 60 will be into 0 because it's acting in the same line of action. 8 sin 60 here acting down into different distances 2 plus 3.5. So I'll write it is clockwise, acting downwards, going towards clockwise. So it is 8 sin 60 into 3.5, that is the distance, that is this 2 plus 1.5 for 8 sin 60 force. Then 8 cos 60 will be 0. If you want to write out, for our confusion, it is whatever it is 0, so you can take it as it is. 8 cos 60 into 0. It is just to avoid your confusion because it's actually a line of action. You need not write this because though you write minus or negative, when positive or negative, it is value is 0. Then at point E, you have two forces, 10 sin 45 acting down, 10 cos 45 acting towards left. Again 10 cos 45 is acting in the line of the same line of action, it becomes 0. 10 sin 45 is acting down, the distance of 2 plus 1.5 plus 3. 10 sin 45 acting down here, and the distance of from point A it is 3, 1.5 plus 2. So 3 plus 1.5, 4.5 plus 2, 6.5. So you can write again plus because clockwise acting down. 10 sin 45 is acting this point, it comes to the clockwise direction to reach point A. That is the meaning. So it is 10 sin 45 into, what is the distance here? It is 3. From here it is 3 plus 1.5 plus 2. That is 6.5. It is 6.5 meter. And 10 cos 45 into 0. You just simply write. It is just to avoid your confusion. You need not write this, but still you can write. So this you will get some answer. You will get a answer of here with some value. And what about this VB? Finally, VA is equal to 0 because VA plus VA is acting the same point. But VB is at this distance, it's anti-clockwise. It has come to point A. VB is another force. VB is equal to, it's minus VB into, what is the distance to be covered? Anti-clockwise, 0.5 plus 3 plus 1.5 plus 2. That is 6.5 plus 0.5, which is 7. Total is 7 meter. Okay. So when you find this becomes 0. This is 0. This all thing is 0. Wherever it is. The remaining you will find an answer of VB. Okay. So suppose Z Newton. Some value it is. Z kilonewton. So what do you want to find out here? You will find out. I'll just rub this area. to continue that. Okay. Fine. What you will be finding? You will write. You get a value answer for VA. Answer you get VB. You have HA also. So these answers you will get. For example, any answer. Listen. Suppose I'll just take VA is equal to 5 kilonewton. HA will be some 4 kilonewton, and VB is some 8 kilonewton, whatever it is. So this step is, after writing sketch, you have to solve sigma H, find some value HA, sigma V to find out some unknown, and go to moment, find out some other answer. So finally you will get a value for VA was here, vertical reaction, HA was horizontal, you found the value, and VB you found out. These three unknowns in this diagram. To find out the support reactions, you find out. After this, there is one more question. This roller, which will take only the vertical action, right? A perpendicular value of this roller will be, it's VB. VB you got a value. But this one, the hinge support, this will take an inclined load also. That is why we are multiplying. We resolved it into two horizontal and vertical component. So if a question is asked, what is the direction of the hinge support, which means a hinge support has got a vertical force as well as a horizontal force, that will have a resultant inclined force also. If the resultant inclined force is asked for hinge support, you will have to show with the help of the sketch, and the answers will be the final answer. In the question it will be given along with this, determine the support reactions of the beam and what is the direction of the resultant force in the hinge support. One more sentence will be added to show that. Now what you have to do, the hinge support is this, you have to draw a sketch. Hinge support, fine, you have to write this one, this is VA. You got some value here, say suppose I just take an example of 5 kilonewton. Maybe the answer maybe you can calculate and get the correct value, and HA will be some direction here, some value, it is 4 kilonewton, both positive, right? Now the resultant will be where it is, some direction. So this instead of writing this arrow mark here, I'll write this arrow mark here, because anyhow it is going in the left hand side. I'll write 4 kilonewton. Now the resultant, okay, VA is 5 kilonewton. The resultant inclined force can only be in this direction, because any force is inclined, its horizontal and vertical component should come and join this. This is what we have studied in the first unit. It's a basic. So please do not forget that. So this will become my RA, resultant reaction at point A. This is hinge support. So this work is to be done only for hinge support, because hinge support will alone have both horizontal and vertical reactions. Is it clear? So how to find out this one? As usual, finding a resultant for sigma H and sigma V. What is the rules there? You take a rules of root of HA whole square plus VA whole square, horizontal and vertical whole square, you get some Newton value, kilonewton. That will be your resultant reaction force. Now how to find out its direction? Direction means at what angle it goes. See, this angle indicates what? At 60-degree line the force is coming down. Is it not? Like this is the resultant reaction, some with, say suppose 10 kilonewton is your answer. I'm just saying example. How to find out its angle? Again same procedure. Your theta is equal to tan inverse of sigma, this is your VA by HA, vertical by horizontal. This will give your theta some degrees, say suppose 56 degree you will get. This is an example. So this you have to indicate with, always the angle will be comparable with only the horizontal line. Whatever the angle you get, you are supposed to write only with the angle is only along with the horizontal line, not with the vertical line. That's our basics. So suppose 56 degree you have to indicate. So this will be your final answer, to indicate the resultant force with the value, resultant reaction with the value, and its direction of action. Direction towards where it's acting. So this problem will be complete if it is asked determine the support reaction zone of the beam alone. You can just show answer of HA, VA, VB, finish it off. Till this it's enough. Okay. One more sentence added, to show the what is the resultant reaction and what is its direction means you will have to show this diagram. Will be a complete question, right? This is very important and it's easier also. Once you write it, it's basically you should know that sigma h, sigma v, that is summation of horizontal forces, vertical forces and the moment. These three makes a problem complete because these are the basic equations of equilibrium, right? So this is the procedure you follow. One or two questions you solve it from your book. There are a lot of questions given. You will be very thorough with this concept.